Hi, I want to show you how easy it is to hook up the 4820 panel board to use as a motor controller. In this case, using this controller, I want to have 4 switches, of which 2 of them I want to go in the forward direction and 2 of them I want to go in the reverse direction. So I chose green for forward and red for reverse. Now the trick I'm going to do with my software is the first green will be a slow forward movement, and the second one be a fast forward movement. To go in reverse, this one will be a slow reverse, and this one will be a full speed reverse. The speeds I can actually control with the pot, so I'm going to wire these 2 pots up. The first pot will control the slow speed, either forward or reverse, and the second pot I will use to control the forward and reverse speed, a fast speed. So if I want to go really slow, I'll turn that very far down and go forward and reverse for fine control of my motor. If I really want to move that motor fast, I will set this speed all the way up for the fast speed, and that's full forward, full reverse. Whoa, maybe a little too much, I'll back it off. So you get the idea. As for the LEDs, I want to hook them up so that the green light indicates that it is running, and no green light will indicate that it is not running. There's 2 ways I can do that. I can either have it so that it stays on, or I will have it so that the motor stops the moment I let go. For control, I want to have it programmed so that the moment I let go, the motor will stop. So this is what I'm going to do. First of all, this is a schematic. This shows an Arduino here on the left, and this shows my 4820 panel here with the proper pin connections. This schematic I actually got from page 7 of my schematic applications. And you can make a copy of it just like I did and sketch out your wiring. So first thing I want to do is I'm going to use a pulse width modulated output to control my motor. Just for fun, I'm going to select D3. D3 is a signal that on the Arduino can do a pulse width modulated output. So we take that, and of course a ground, and I will wire those 2 to my motor controller. I will then take my 4 switches, switch 1 common, or excuse me, just a switch 1, and I will wire that up to D4. Switch 2 I'll wire up to D5, switch 3 to D6, and switch 4 to D7. Now I'm not going to worry about multiplexing this right now, so the switch ground, I can just leave that tied to ground. And the switch common, which in this case I'll use pin 21, I will tie that direct to a ground pin on the Arduino. So I have the 4 inputs controlling the Arduino, and I have the output controlling the motor. The 4 LEDs I want to use, I will connect to digital outputs also. So we're going to do this. LED 8, which is actually this last one here. I'm going to connect that to a output D8 of the Arduino. LED 6, let's connect that to D9. LED 4, and I'll connect that to D10. And LED 2, I'm going to connect that to D11. So using those 4 outputs, I have control over my 4 green LEDs. If I want to use the red LEDs, great, I can just wire some more connectors to control those lights. And remember too, even though these are analog inputs, you can also use them as digital outputs. So I still have plenty of digital pins that I can use to control the other lights. The last thing I'm going to do, I have the switches wired up, I have the LEDs wired up, and I have the output wired up. But I want to control both pots. I want to read both pots. So I'm going to take the pot low signal and tie that to the ground. Take that one there. The pot high signal, and I'm going to put that to plus 5 volts. So that's going to put my 5 volts across these pots. So I can turn the pot up or down, and I will get a proportional voltage anywhere from 0 to 5 volts. The first pot I'll wire to the Arduino's A0 input. The second pot I'm going to wire to the A1 input. And I am done. I now have the 4 switches, the 2 pots, and those all go into the Arduino input. my software will read them, and from that it'll control these 4 outputs to light or not light the LEDs, and it'll also control the pulse width modulated signal to control my motor speed, forward or reverse. In my actual controller I'm using, I have a separate signal to control forward or reverse. So I'm going to take another output, in this case my D2, and that's going into my motor controller. So now I have complete control of my motor from this 4820 panel board. Slow reverse, full speed reverse, slow forward, and full speed forward, with speed adjustment control right here. So now this is all wired up. I will hook it up and start writing my program, and let's just see how this thing works. Okay, let me clear up one thing. You may have had a question about this. I wired up my LEDs, but I did not mention wiring up an LED common. I did mention wiring up the switch common. The switch common is tied to ground through the jumper. But I did mistake to mention that the LED ground and the pot ground jumpers are also by default installed. I will cut them off if I need to, but I do not need to. There's going to be no multiplexing that requires that. So what we have, even though I didn't specifically mention it, is the LED common, the switch common, and the pot common are all tied to ground. Just to make it clear, for illustrative purposes, let's just say I take the LED common, and that's tied to ground here, and the pot ground here, which is also tied to ground. So although I did not really mention it, these 3 jumpers are connected, and therefore all 3 switch, pot, and LEDs are connected to ground through there with those jumpers. Okay, so I wired up the circuit as my drawing indicated. I built this prototype here, connected to an Arduino. This is my DF robot. It's a dual motor controller, of which I'm using 1 channel. And over here I have a motor driving some gearing. And I wrote a small program to check it out. So we're going to verify this. First I'll put the switch 1. We'll drive the motor in reverse. And that works. The second one we'll do it at slow speed. And the first green one is slow speed forward. And the last button is full speed forward. As you can see, the first pot is used to control the speed of the motor at slow speed. So we'll do this. I can set it to too slow, up to about 50%. And the second pot controls my fast speed, so I can run that from full speed down to about 50%. And the other thing I did in the program was make sure that I wasn't able to activate both buttons at the same time and cause some trouble with the motor, such as if I do forward or reverse, it's only going to use reverse. If I do low speed and fast speed, it's only going to do fast speed. Same for forward or any other combination of motor buttons. And as you can see, the green light goes on for each button that I press. So now that that works, let's see if this circuit and mechanics work in an actual situation.